Okay. What are you doing? What about having a serious discussion on gravity? I spent an enormous amount of time thinking about field theory, but I'm never interested in theory. I'm always interested in how it actually works. We all, of course, have been brainwashed with movies and the garbage that we were taught in high school or college. And I work from the perspective of what if there were a more advanced group of people on another planet that were far more technologically advanced than us? How would they explain it to their little children? I don't actually start with that premise before thinking about these topics, but it must be irreducibly simple. What if a far more advanced people were to correctly understand the nature of field theory? Like I said, if you can't explain it to a child, then you certainly don't understand it. So let's get to the heart of the matter on gravity. Yeah? Gravity, of course, has no center, and what does that mean? Well, it has a point, but it's the point inside the mass. There's a lot of things that confuse people. And of course, I always laugh when people say, there's no such thing as gravity. And I just say, well, jump off of a stool and tell me what that phenomena is. And I've said something like that many countless times, and of course they never have an answer. It's easy to, poke the bear. Not that I'm saying I'm a bear, but, unless you have some intelligent answers yourself, then, saying stuff like gravity doesn't exist is rather ridiculous. I said in simple that, of course, a field is nothing other than an ether perturbation modality. Here's another irreducible fact, and I've said it many countless times, and there's nobody on this earth, and I mean this seriously, not egotistically, seriously, no one on this earth can refute it because it is 100% undeniable. No one else has said it. That means I'm boasting about it, but there's only two different types of field geometries. One is toroidal, or you could say anti-toroidal, right? And the other one is a hyperboloid. Hyperboloid is an hourglass shape. Negative image of a hyperboloid is a torus. Negative image of a torus is a hyperboloid. The one word that a lot of people love to talk about field theory and energies and, even the people that, put the crystals on and, those kind of energy people, they love to use this magic word, vortex. Vortex is like a magical, almost magical science fiction word. And people say, what is a vortex? Well, it's like they can't really tell you. It's like, the vortex when you pull the drain on the bathtub and you see this neat little vortex. And, I, same as you, probably fascinated by the vortex when you pull the plug at the bottom of the bathtub and you see the fast. But what is a vortex? A vortex, of course, is nothing other than the half cross-section of a torus. If you take a donut, say a large puffy donut, right? Maybe a small little center. Of course, they're all toroidal. You slice it right there along that axis, as the donut's laying flat on the ground. Of course, an apple is kind of an oblate torus. Slice this apple right here. You see right here, there's this neat little, it's a vortex. So that's all a vortex is. Of course, it would be less fascinating to say vortex than to say half toroidal. But that's denotatively more accurate. If a child knows what a torus is and saying, well, it's half toroidal, there's a vortex. What's a vortex? I know what a torus is, one of the first things taught to me in school, right? Which, of course, kids are not taught at all. But what's a vortex? Fascinating vortex. Well, once again, there's only two field geometries in the entire universe. The torus and the hyperboloid. Interestingly enough, of course, there's only two fundamental field modalities. One is not a modality, is dielectric or electrostatic, and that is most closest to the ether, or aether, whichever pronunciation you like. What if we could explain gravity go a whole lot deeper? And this is something you need to think about, and if you actually think about it, you'll realize how true it is. Just a little list of things to think about, and there are things I actually haven't ever discussed about gravity before, and they're actually extremely important, and nobody thinks about them. So let's get to it. And of course, at the center of gravity, there is no gravity. I don't know if you ever see this movie. It's called The Core. The Earth is all upset, and it's a movie, and of course, it's a science fiction garbage movie, and they develop this drilling vehicle where they're going to restart the core of the Earth, blah, blah, blah. It's all garbage, of course, and they go to the center of the Earth, and yet they're all still walking in the inside of that magic core drilling vehicle. They're all the way at the center of the Earth. It's like, what's holding them to the bottom? And of course, science fiction movies, they don't answer any important questions. They're just stuff to excite people. You eat popcorn, you watch something. I know this, and of course you know this. What's holding them to the bottom of that vehicle? You know, this is a serious question to ask about, of course, a silly movie, and this video is not about that silly movie, of course. But what's holding them to the bottom of that vehicle? They're already at the center, like about midway through the movie. They're at the center of the Earth. What's holding them to the bottom of the vehicle? The center of gravity, there is no gravity. Well, that's an accurate statement that's undeniable, but what is the importance of that? Well, if you actually apply Platonic retroduction to that, it is incredibly telling about what gravity is. You know, A leads to B and B leads to C. So applying, wow, it is incredibly windy out there. It's like Toto, you know, where Dorothy from The Wizard of Oz, you know, where her house gets lifted, it's like must be blowing like 35 miles an hour outside. Sorry about that. I'll edit that out of this video. So, gravity of a mass has a vector, but it does not have a center. Yeah? What does it mean, a vector? I think you know what a vector is. So we have, say, like a super body here, and you know, a moon or an asteroid or even a meteorite. You know, gravity has a vector. Of course, they are both mutually moving, not towards each other, but towards a null pressure point in counterspace, but that's a matter for further discussion in this video. But that's the vector of gravity. But what does that mean? Gravity doesn't have a center. Gravity has a vector. Just think about that for a second, you know, while you're soaking in the bathtub or you're taking a shower. And let's just delve into that further by applying retroductive logic to the fact of what we know about these field modalities, because people love to talk about grand unified theory, magnetism, dielectricity, electricity, and gravity. Well, there's no such thing as gravity. That doesn't mean that this phenomena doesn't exist. Of course, it does exist. It means it's not an autonomous field modality. And it's not a curvature of space-time vis-a-vis relativists, because time is only a measure of magnitudes. Time is not a thing. It doesn't act upon things. It is a measure. A measure is not a thing. A measure is relational to something else. Time is no different than other things that don't exist, like waves and emptiness. Emptiness relational to what? There's no such thing as emptiness, because emptiness by genuine definition, of course, would have to have an attribute, and it doesn't. So nobody could even conceive of it, because it has no attribute. Nobody could even dream of or conceive of anything that doesn't have at least one attribute. Waves don't exist either. Waves are not a thing. Waves are what is done by something else. Gravity is also too not that. There is not an autonomous field modality. No such thing as gravity. In other words, it's not an autonomous thing within natura naturans, or Mother Nature. Obviously so the phenomena exist, but what thence therefore is gravity? Keep it really, really simple, and I'm going to keep it really, really simple like this is an elementary school. I'm not saying you have a mind of an elementary school student, but I mean, if you can't explain it simply, then you don't understand it. And the words that I'm using in this, if you think I'm using big words, then that's not an issue with me. That's your issue, and I certainly don't ever intend to use big words. I mean, to me, these are not big words at all. Dictionary.com is a good place to go, by the way. So gravity has a mass. I mean, gravity of a mass has a vector, but not a center. You know, let's get on to the important point, yeah? Magnetism of a mass, for example, has a vector, but not a center, yeah? Does a donut have a center at its vector of acceleration? No, I mean, what's in the middle of a donut? There's nothing there, right? I don't want to say counterspace regarding a donut that you might eat, like a powdered donut. But I mean, at the center of a magnetic field, and this is demonstrable with a Gauss meter, there is no magnetism. There is no magnetic flux. Center of magnet, you know, this mass that we call a magnet. Say this is a magnet, stick a probe right at the center. There is no magnetic flux. Center of a mass, which has a vector, but there is no gravity at the center of a mass that has a vector that we call gravitation. Of the vector of magnetism when it's centrifugal, and of course gravity is centripetal. Those are not big words either. Gravity is centripetal vector, and magnetic flux, of course, is force in motion. The vector of gravity, of course, is increasing inertia and acceleration, that vector. But they don't have centers. Center of a magnet, there is no magnetism. Center of a mass, there is no gravitational vector. There is no center of gravity. This is incredibly important in applying retroductive thought and analysis to the thought experiment, which is accurate, not just an experiment or theory, because these are facts about gravity and magnetism. So magnetic mass has a vector and not a center. Light has a vector. We'll get to explaining gravity very shortly here, but I need to tack this on to the end of that. Light has a vector, but it does not have a center, because its center is dielectric pulses that are conventionally called photons, but of course photons is an abstraction. I've talked about this endlessly. So light's vector is of course helical and repeating. This is what human beings call frequency or wavelength. But light itself has no center, because when people talk about light, they're talking about TEM, transverse electromagnetism. We're talking about frequency, X-ray, visible light, gamma, radio waves, blah, 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 X-rays. They're talking about a frequency and a wavelength. But the center of light, there is not light. Light is a compound coaxial circuit. Center of light, there is not light. When we talk about light, we're actually talking about its helical component. So the vector of light is what human beings call frequency of wavelength. It's helical. Yeah. Gravity has a vector, magnetism has a vector, light has a vector, but it does not have a center. The center of light is not light. What human beings call light is the attributional nature of its electromagnetic frequency wavelength. Electricity, too, also has a vector, does not have a center. Yeah? So let's get on to gravity here and apply retroductive logic to the facts that we know about gravity and what it is, and most importantly, what it is not. Because really, really good detectives, when they're interviewing a criminal, they're not so much listening to what they say, they're paying attention to what they don't say. So gravity has a point of inertia, yeah? But that point of inertia is actually outside of the mass. Talk about that in just a second, right? A magnet has a plane of inertia relational to its mass because, of course, a magnet is mass polarized. That's the only thing that denotes a magnet is its qualitative nature, not its quantitative nature. It's mass polarized. The plane of inertia, never said this in any video, but it's factual. Since I'm an expert on magnetism and magnets, right, which of course I am, even to the people that hate me, a plane of inertia is a planar point source field. Let me repeat that again. A plane of inertia is a planar point source field of, specifically, a polarized object, i.e. a magnet. Gravity is incoherent relational to the mass. Incoherent mutual mass acceleration, but they're not mutually accelerating towards one another, but towards the lowest null pressure point between both. Incredibly important in applying that retroductive logic to that fact of gravity, which is a vector, but there's no center of gravity. There is a point of gravity, but we'll get to that in just a second. Like the ferrocell, for example. I know I've got countless videos of that, or the supercell. Shows the point of gravity is outside the mutual masses. You can actually take two magnets. And of course, there's no such thing as magnetic attraction. That's dielectric acceleration. That, of course, is acceleration. That's not force in motion. That's inertia and acceleration. It is a vector towards the lowest null pressure point of counterspace. You may say in counterspace, but you can say of counterspace. This, of course, is wordplay talking about of counterspace or in counterspace. We don't need to get on to getting into the minutiae of that. But so the center of a magnetic field is not magnetism, which is demonstrable with a Gauss meter. It's dielectric. There's no magnetism in the center of a magnet. Fact. Not my opinion or theory, it's fact. The center of a mass, there is no gravity. It's dielectric. There is no gravity there. So gravity has a vector, but it has no center. It does have a point, but a center of something, of course, is always within somewhere. This X, this object, case of a magnet or a mass that we would say, gravity, the vector of gravity of this moon or the star or, XYZ planet. So gravity of a mass has a vector but no center. All gravity, of course, is a curvilinear vector. Curvilinear vector is just another way of explaining a vortex. Curvilinear vector, three-dimensional vortex on multiple planes, but getting into explaining that, of course, is harder to think about. Some people can visualize that easily, some people cannot. All gravity is a curvilinear vector towards counterspace, not towards the mass. You can see this underneath the supercell. It is fact. Ignorant people will see two bodies accelerating in space. Not that human beings have seen that I ever recall. Accelerating and crashing into one another, actually curve around each other like comets eventually do. It even takes some of these comets take thousands. If you just keep going on, they'll eventually spiral. Of course, the sun, for example, is not spinning along with it. Spiraling in towards each other. In the case of super huge masses that we've seen in actually deep space, spiral in towards each other and crash into each other. But they're not accelerating towards one another. They're accelerating towards the lowest, nullest pressure point in counterspace between the two. And then, of course, you're just looking at an invisible vortex in space. Space has no properties, by the way. The notion of curved space-time or bending space is the one and only thing Of all the written records we have of Nikola Tesla where he fumes at the mouth, not literally, fumes at the mouth at Einstein for, reification of space as having properties, which space cannot have properties because I've explained space endlessly in countless other videos, but let's not get into that one right now. So the center of something is within that X in relational to gravity, but also too in the case of the magnet. All gravity, like I said, is curvilinear vector towards counter space, not towards the mass. This is simplex electrostatic or dielectric field torsion. Same as static cling. You ever pulled your hand out of a box of packing peanuts and you're stuck to your hand, you can't let them go, especially if it's dry, obviously so. That is no different than so-called gravity. It's an acceleration towards counter space. It's dielectric. Yeah. The inversion of this ether rarefaction or torsion, this electrostatic torsion, this thing that we call gravity. The same thing human beings have talked about magnetic attraction, which does not exist. So-called magnetic attraction, of course, is not a force. You let go of one, say two super powerful neodymiums, they'll actually jump towards each other. They're actually not jumping towards each other, no different than mutual mass acceleration in the case of gravitation. They're actually accelerating towards the lowest null pressure point in space. Now, if you were to see two magnets jumping together, as humanity has seen due to lodestones, well, that's magnetic attraction. Here's a magnet, here's a magnet. They're accelerating towards one another. Well, that's magnetic attraction. Well, magnetic attraction doesn't exist. That's a correct observation, but an incorrect explanation. Two magnets accelerating towards one another, well, that's magnetic attraction. Correct observation, incorrect conclusion, and totally incorrect explanation. When masses are accelerating towards one another like two magnets do, that is not gravitational attraction. The phenomena of gravity, sure it is. Well, they're vectoring seemingly towards one another, but gravity doesn't have a center. Gravity has a point, but the point is always outside the mass of either, well, you have to have two objects that are accelerating towards one another. I mean, we're going to observe gravity other than the mutual mass acceleration that actually made the supermassive object to begin with in the case of Earth or Moon or Sun or Star or asteroid, whatever. You have to have two or more objects, obviously. So yes, of course we do. Sure, well, that's gravitational attraction. Is it? Once again, there's only two field geometries in the entire universe, the hyperboloid and the torus. The geometry of dielectric is the hyperboloid, that's increasing inertia and acceleration towards counter space. Even the toroidal geometry, because magnetism is the dielectric field, the loss of that energy or inertia of the dielectric manifests the centrifugal force vector of force and motion, which of course is the toroidal geometry, just like this apple. It's not a perfect torus, it's an oblate torus. We actually have a proportionality of 5:1 in the case of this fake gold apple. But a vortex, once again, is nothing other than a sectional portion of a torus. So the point of gravity is always counterspatial. Not center, point. Yeah, I made a distinction there. Yeah. Not point center. Well, that's just wordplay. No, it's different. Yeah, just think about it for a second, okay? The mass of a gravitational object, gravity has no center. At the center of a gravitational mass, you travel to the center of the Earth, which of course we can't do. Science fiction movies can do it. There is no gravity there. You can actually test any magnet with a Gauss meter at the center of a magnet. You take two magnets, bring them together, create one magnet. There is no magnetic flux at the center. There is no gravitational phenomena at the center of a mass of gravity. Of course, a point of inertia is, as meant, counterspace. The point of inertia, that's the reason why the center of a magnet, there is no magnetism. The center of a mass has no gravitational center. It has a vector, but no center. The point of magnetism is the plane of inertia. There is no magnetism there. The point of gravity, in the case of gravity and gravity's vectors, we have to have two or more objects. The point of gravity is also two, counterspatial. Say there's only two things in the whole universe, and they're accelerating not towards each other, but if you look at them, same thing, foolish human beings have done for thousands of years. Two magnets accelerating towards one another. That's magnetic attraction. Correct observation, incorrect conclusion. Only two objects in the entire universe are accelerating, seemingly, towards one another. That's gravitational attraction. This phenomenon is gravity. No different than a person jumping up and falling down. No different than this, right? Oh, look, there's gravity. Yeah, well, that phenomena is obvious, but the stone is not accelerating towards the Earth. What it's doing is erasing out space and actually accelerating towards the lowest null pressure point between the two. Everything I've said in this video is 100% undeniable. It explains all phenomena simply. Yeah. There's only two geometries of the entire universe, the hyperboloid and the torus, and a vortex is nothing other than, of course, a partial torus. Everybody loves to talk about a vortex. I encountered that for decades in my life. So the point of inertia is counterspace. Yeah? The point of inertia of a magnet is called the plane of inertia. The point of inertia of two or more masses, let's just keep it simple, two masses, right there, there's nothing there. The center of a magnet, if you're able to stick a hole in this, which you can do, there's actually magnets like that, there's a void in the center of the magnet. There's nothing there at all. Really powerful magnet. Nothing there. In other words, there's an empty void at the center. There's nothing there. The plane of inertia still exists there. When you actually bring two magnets underneath the supercell, you can see the plane of inertia forming before the two magnets actually touch. Same in the case of two accelerating objects that are seemingly accelerating towards one another, but are not, is the point of gravity, and that is counterspatial. The point of magnetism, what we call the plane of inertia, is also too counterspace. Magnetism has no center. It's toroidal. It is the force and motion centrifugal vector of the magnetic toroidal field. Gravitational masses, unless of course they're straight on, are toroidal vortexes. This is also, too, undeniable through all observation throughout all history. A vortex, like I said, is just a half-torus acceleration. Applying retroductive facts and logic to the known phenomena that have observed throughout all of history and what we know about gravity, well, actually we have to erase everything we seemingly know about gravity and seemingly know about magnetism, because there's no such thing as magnetic attraction. Masses do not accelerate towards one another like, say, two bodies in space that are, spinning around each other. They're actually like things going down the rain and are eventually going to crash into each other. Or, even this phenomenon, like this stone is going to crash into the earth. Say it's a super huge stone, creates a crater. Gravity has no center. Magnetism has no center. Gravity, same thing with the phenomena incorrectly called magnetic attraction, have a point, but that point is the null pressure point in counterspace. Don't you find it fascinating? Just think about it. Because there's fundamentally, from the standpoint of Mother Nature, who's nothing other than a dreadlock-wearing, hairy armpit hippie chick with like a hemp skirt and muddy feet. She keeps things really simple. There's no difference between the the point of gravity, I'm saying two mutual mass objects that are seemingly accelerating, right here. There's nothing here. So there's two things only in the universe, accelerating towards one another, not really towards one another once again. And right here, they both are accelerating towards this here. There's nothing there. There's nothing there. Yeah, that's that same nothing that you can see underneath the supercell or the ferrocell, which anybody can make. Even a 10-year-old can make one. Well, you can actually see the plane of inertia. There's nothing there. You're right. Nothing. There's a difference between no thing and nothing. They're accelerating. You see the plane of inertia forming. When two magnets come together, they actually create one magnet. And they have a plane of inertia right between each other. And the plane of inertia on this magnet, right down the middle, same thing on this one. But when they come together and they make one magnet, like super powerful magnets that I have over in the other room, can't get them apart. Once you get together, forget about getting them apart. You can, but it's essentially impossible unless you use wooden wedges and hammers and all that stuff. There's nothing there, but all of a sudden the plane of inertia moves right to the middle there. But, you can see it forming before they actually get together. Neither gravity nor magnetism have a center. They have a point. What does this tell you about gravity? That at the center of a mass there is no gravity, and the center of a magnet there is no magnet. Simple field torsion. Everything is pressure mediation in Mother Nature. The plane of inertia, like I said, what was an interesting quote? Plane of inertia is a planar point source field of a polarized object. In this case, we're talking about a magnet. The only difference is it's a polarized object, and that's the only distinction between mutual mass acceleration and two superhuge masses, or even the Earth and the stone. Incoherent mutual mass acceleration versus polarized mutual mass acceleration in the case of two magnets, for example, or magnets and inducted magnetic field of, say, iron filings, for example. You can hold a magnet over iron filings, and they were actually induced to the magnetic toroidal field, which, of course, accelerates the iron filings against gravity, away from. The reason why the Platonists and Pythagoreans, created stuff that's so amazing, even these countless thousands of years later, not countless, but many thousands of years later, is because they applied retroductive logic to these principles and secrets of nature. I see gravity really simply for what it is. Gravity has no center. It does have a point at the center of a gravitational mass, what we think is the gravitational mass, any mass. Yeah. Use the Cavendish experiment, these two huge lead balls and low friction joints, and they would actually slowly spin towards what. You ever look up the Cavendish experiment? It is incredibly important, applying retroductive logic, to the fact that the center of gravity there is no gravity, and the center of a magnet there is no magnet. Just think about that. If you're interested in this topic, of course. If you're not, forget about it. But there's no YouTube video out there about these facts. Thanks so much for watching. I hope you liked this video. If you do, any donations warmly welcome. You can tell me how much you hated it. Thank you. Goodbye.